Okay, finally, the last installment for binomial expansion. And this really isn't about binomial expansion in this last example, but this is really basically come into saying, hey, how can we take an equation and, rewrite it into a binomial raised to a power? And particularly in these examples, we're just going to write it as a binomial squared. So that's really kind of going to be the focus of this. And I do have, some additional resources that we'll go over in this, as we'll be covering this process, which is called completing the square, later on in the videos, or later on in the notes. But I really just wanted to kind of come into, so far we've been always, been looking at these equations that are, written as a binomial, squared. Well, what if we don't have that and we maybe prefer, written in that format? What are some of those advantages that we can write? And particularly one of the main advantages of looking at something in vertex form is you can see from these transformations. It was pretty easy to identify the transformations when it was written in this vertex form. When we have something in what we call standard form, it's a little bit difficult to be able to understand where, how is this function being transformed? What is going on with everything? So that's one of the advantages of using the vertex form, is we can kind of very easily see the transformations. Now you can see that I'm doing 6 examples here, so it is going to take me a little bit to kind of go through each one. So you can obviously just go and check in on the example that you need help on, or that you feel like you want the most instruction for. So I will kind of break down the general process with this first one slowly, because each and every one of them after that is a little bit more advanced. So I'm not going to spend as much time talking about the basic and the ideas of, completing the square step by step for the rest of the examples. But in this first one, let's kind of take it step by step. All right. So to complete the square, basically our idea is to write an equation. I guess I'll just have to rewrite it, right? Our basic idea is take an equation that's in standard form and rewrite it in the form of a times b, or let's forget about the b. Let's just do x minus h squared plus k, right? We basically want to write something in this format, in the vertex form. So we want to take an equation like this and write it like that. And basically you can see what we have is a binomial squared, right? So we need to create a binomial squared, and that's the process of completing the square. All right, so the way that I like to do this first is, since we're taking something in standard form to vertex form, we can keep the y there. So I'm not going to change the y. And everything we're going to do is going to be on the same side. I'm not going to add or subtract operations to both sides. I'm going to keep everything on the same side. But the first thing we want to do is, we understand that a binomial squared comes from having what we call a perfect square trinomial. So for instance, let's just do a little bit of backstory here. If I did x plus 1 squared, we know that's x plus 1 times x plus 1, right? Which simplifies, if you apply, FOIL distributive property, that simplifies to x squared plus 2x plus 1. This is what we call a perfect square trinomial, okay? A perfect square trinomial can be factored into 2 binomials that are exactly the same. And we don't write to the factored form like this. We can write it as squared, which is exactly what we're looking for. So the process of completing the square is finding a value that is going to make a perfect square trinomial. Here, this is not a perfect square trinomial, all right? And this is not even factorable. So what we're going to do is we are going to create a value that's going to create a perfect square trinomial. Now, you might say, okay, you're kind of starting to lose me here. So what we're going to do is we're going to group our first 2 terms. We're going to say, all right, these 2 terms, x squared minus 2x, I want to create a perfect square trinomial from here. So what that means is I need to find a number that is going to make this a perfect square trinomial that can be factored into the same factors. All right, because 5 doesn't work. So I need to find a new number to do that. Now, once you get a little practice, you don't really need to, follow these steps, as slow as you can, but there is a process to doing it. And this is especially helpful when you're doing problems that are fractions or anything else that are a little bit more difficult. To find the value c that, what we say, completes the square, and actually another way to look at it like this, y equals, and you guys might have seen some of these. We did these examples in Algebra 2, is basically finding a value c that completes the square, that creates a perfect square trinomial. So to find c, basically all we need to do is take our b, which is -2, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. Negative 1 is 1. So now I can add 1 in for C. And now what I have is a perfect square trinomial. Y equals x squared minus 2x plus 1. And then plus 5. Now the issue is you can't just add a 1 to an equation and say, okay, I'm good. I added a 1 to the equation. I have a perfect square trinomial, because now you like undid the balance of the equation. So a lot of people, and I've taught this as well, especially when you're solving, you want to add to both sides. Well, we don't really want to add to 1 because we want to make sure everything's solved for y. So we don't want to add a 1 to both sides. So instead of adding a 1 to both sides, I can add and subtract to keep the equation balanced. Because if you add 1 and take away 1, it's still going to be, the same result. The difference is this 1 is inside this parenthesis. This is my perfect square trinomial, which looks very, very similar, by the way, to my random example I decided to do, right? This is x plus 1 times x plus 1. And if you look at this, if I tried to factor this, the factored form of this would be y equals x minus 1 times x minus 1. And the cool thing about completing the square is that every single time you do this b divided by 2 squared and you add that into the parentheses, you're always going to get a trinomial that is factorable. Always. Now, some of them are not as obvious as far as the factor form, so I will talk about that on some of the more difficult. We'll talk about that, like as far as what that is, but it's always going to be factorable as a perfect square trinomial. So now I can just rewrite this as, and again, 5 minus 1 is 4. I can rewrite this as y equals x minus 1 squared plus 4. And there you go. Now I've taken this equation and I have written it as a in vertex form. Now, I'm not going to go through all the questions like here, but you can see it's now in this format where if I was to ask the questions on y-intercept, zeros, transformations, parent functions, then you could obviously go ahead and answer them because now it's in that standard form, and it might be a little bit easier for some of those questions. Okay, so now I'm going to work on a little bit quicker going through this, and the whole process of completing the square basically depends on the fact that I have my x squared has a coefficient of 1. So I didn't write in a 1 there, but you can see that there's no numbers in front. So it looks like for the next 4 out of 5 examples, I put a coefficient in front of there. And that really is going to trip up a lot of students. So I'll take this one a little bit slower. And then for the other ones, I'll just kind of, move a little bit quicker. But the process, the step-by-step process is exactly the same. First thing we want to do is group the terms, group our first 2 terms. So y equals negative x squared minus 6x plus 3. Here's what I want to create a perfect square trinomial out of. Now again, I can only complete the square when my x squared has a coefficient of 1. So I'm going to factor out a negative 1. That turns to a positive 6x plus 3. Okay. Now I need to find the value c. I'm not going to write another line finding c, but I will say, all right, to find that new value, I need to take my b. Oh, I didn't write that in there, did I? B divided by 2 squared. That's what I did. B divided by 2 squared. Okay. So my b in this case is 6. So I'm going to take 6 divided by 2 and then square it. So 6 divided by 2 is 9. 9 squared. Oh, 6 divided by 2 is 3. 3 squared is 9. Okay. So I'm going to add the 9 inside the parentheses, right? And then I'm going to subtract the 9 outside the parentheses, just like I did over here. So I'll have negative 1 times x squared plus 9, plus 6x, sorry, plus 6x plus plus 9. I'll just do that in blue because I really think the color change here is going to be really important. So I think you guys understand we're going to add 9 and plus 9, but then I got to make sure I subtract a 9, right? And now the important thing is I really am not adding a 9 here. I'm adding a 9 that by distributive property is being multiplied by a negative 1. So when I subtract a 9, I also need to multiply this by a negative 1, right? Again, everything is about keeping everything equal. If you add a 9 that's being multiplied by a negative 1, well, when you subtract a 9, it also has to be multiplied by a negative 1. And then don't forget the 3 on the outside. Okay. Now, this creates a perfect square trinomial. And again, you could factor in saying what two numbers multiply to give me 9, add to give me 6. Hopefully that comes rather simple to you because we've been practicing some factoring and we'll be doing more of that coming up. But we have, or at least from your like preparing for pre-calculus section, this turns into x plus 3 squared. Negative 9 times negative 1 is now a positive 9 plus 3 is 12. And there you go. Now it is in factored form. You don't really need to write the negative 1. You can just keep that as a negative. But then again, you have this non-vertex form where you can figure out the rest of the transformations. All right. In this example, we have a number in 2. So it's basically, again, the same process. You're going to, this one I'm just going to factor out the 2 because I know it can't be there. Just make sure you factor out the 2 from the 8x as well. Okay, I need to find my value b that completes the square. So I'll take, and I'll do the last one color coordinate, and then I'll just use the same color. So in this case, I'm going to take my b divided by 2 and squared. 4 divided by 2 is 2. 2 squared is 4. So that is my c that completes my square. So I'm going to add that into my equation. So y equals 2 times x squared plus 4x plus a nice purple 4. And then remember, you got to subtract a 4. But I'm not really adding a 4, am I? I'm adding a 4 that's being multiplied by 2, right? Because this 2 is outside parentheses. So this 2 is multiplying by everything inside the parentheses, including that 4. So when I'm adding this 4, I'm adding a 4 that's being multiplied by 2. So when I subtract the 4, I also need to multiply it by 2. And then just don't forget that minus 1 at the end. Okay? So now I look at this and say, all right, I created a perfect square trinomial. What two numbers multiply to give me 4, add to give me 4? And that's going to be x plus 2 times x plus 2, which is just be written as x plus 2 squared. Negative 4 times 2 is negative 8. Minus 1 is negative 9. Okay? All right. Now, let's get into ones with some fractions. This is where the fun starts to begin, okay? You know what? Let's change this. Sorry about that. I'm going to change this one up. Let's do this as a, sorry. I'm going to black. Let's change this to a 2. And let's change this to a 3. Okay. I just want to do get some different types of examples here because that one, yeah, okay, perfect. Okay. What was I going to do? Oh, okay, we're doing this one. All right, so this one's kind of nice because, hey, I don't have to factor anything out, right? It's kind of an annoying kind of task to do with these types of problems, you know, that factoring out. And remember, because I make the mistake, you know, and a lot of students are going to make the mistake. So it's kind of nice when we don't have a coefficient. We can just say, all right, let's group the first two terms, right? And let's find the value b that completes the square. So I'm just going to take negative 3 divided by 2 and square it. Now, this problem comes in a little bit of an issue here because in this case, I can't divide 3 by 2. So I'm just going to have to leave this as a fraction. This becomes 9/4. Okay? So again, I'm going to have to add and subtract 9/4, which doesn't look like it's going to be that much fun. But you'll see that it's not as bad as you think it is. Okay, so usually students can get to this point, they're like, all right, I get it. I have no idea how to factor this, though. What two numbers multiply to give you 9/4, add to give you negative 3? I understand factoring what two numbers multiply to give you 9, add to give you 6. Like, I get that. I get what two numbers multiply to give you 4, add to give you 4. I get that, right? So what we got to do is start looking at some patterns. And what we notice is, take a look at, to go from here to here, this number is really just b divided by 2. b divided by 2 is 2. There. Let's look over here. b divided by 2. b divided by 2 is negative 1. There, negative 1. So rather than trying to like factor this, just take your b divided by 2, which is just negative 1, negative 3/2, and that's going to be your factored form. So guess what? Now, I mean, I'm going to have to do this fraction, but at least as far as the factoring portion, this is easy. All it is x minus 3/2. It's already written for you. We already got it. Now, you can look into factoring this, and that's a whole different kind of avenue, but we don't really need to be concerned with that. You can see that's factored there. Now, what about here? So the best way to simplify this is to rewrite the 1 as a fraction of 4 over 4. And there now we can rewrite our answer as -3/2 squared. And this would be 9. So now since I have common denominators, you can just add the numerator. So that's 9 -5/4. And boom, there we go. All right, so now we're back to factoring out some terms. Lovely, lovely, right? All right, same kind of example though. Same kind of at least thing we're going to do is let's factor out a -2. So by factoring a -2, I get x squared plus x minus 3. Now in this case, my b is 1, so I'm going to have to take 1 divided by 2 and square it, which gives me 1/4. Now that 1/4, remember we're going to add and subtract that 1/4 inside of there, right? So I have -2 times x squared plus x plus 1/4. Got to make sure I subtract the 1/4. Then again, though, I'm not really adding a 1/4, am I? I'm adding a 1/4 that's being multiplied by a -2. So I got to multiply by -2, and then also just don't forget about that -3. It's still there, okay? Now again, factor what two numbers multiply give you 1/4, add to give you 1? Hey, it's just b divided by 2. Now again, this is positive in this case, and you can see that that would make sense for my binomial squared to be positive, because x plus 1/2 times x plus 1/2 is going to give you 1/4, because 1/2 times 1/2 is 1/4, and 1/2 plus 1/2 is 1. So it works out every single time. That's the beauty of completing the square. Squared. Now here, I can multiply my fractions. So 1/4 times -2, I can simplify that to a positive 1/2 minus 3. Right, because this is negative times negative is positive. So 2 over 4 reduces to 1/2 minus 3. Now I'm going to want to rewrite my whole number as a fraction. So just practicing some fraction operations so we don't get, make sure we keep up to date with these. Don't want to lose everything. So what I'll do is just rechange this to -6/2. Is 6 over 2 the same as 3? Yes, but now I can apply my operations just a little bit easier. Or actually a lot easier. It's a little bit more work for me writing it, but I'm okay with it because I know I'm not going to make as many mistakes when I write out all my steps. But you can easily kind of skip through some of those, as you kind of feel a need for. All right, last but not least. Now, so before, we had fractions and everything worked out great. Now we have one where we have to factor out the 2, but you can't factor out a 2 from 3. So what do you do? Well, in this example, we're going to need to factor out the 2. So we're going to factor out the 2. Now, again, factoring out is really just like the same thing as dividing out, right? You're really just dividing a 2 from 2x squared and a 2 from 3x squared. So when you divide a 2 from 2x squared, you're just left with x squared. When you divide a 2 from 3x, you're going to be left with 3/2 x minus 3. Now, if you're not sure if I did that correctly or not, just take the 2 and multiply it back. 2 times x squared is 2x squared. 2 times 3/2 x is just going to be 3x. And then we have our minus 3. Now, here's where a lot of the fun begins. Remember we got to do that b divided by 2 squared? Yeah. All right, so let's do it. Our b is 3/2. 3/2 divided by 2 squared. What the heck do we do here? So remember, if we have fractions, let's kind of do some fraction operations. 3/2 divided by, that's really 2 over 1, right? And remember, dividing by a fraction is the same thing as multiplying by its reciprocal. Hopefully I have some more room. No, I don't. Crap. So I can rewrite this as 3/2 times the reciprocal, which is 1/2 squared. So I do have more room, so let's keep that in there. So in reality, that's going to be equal to 3 over 4 squared, which is equal to 9/16. Pretty crazy, right? But it's good. It works. Okay, so that's our 9/16. So I'm going to have y is equal to 2 times x squared plus 3/2 x plus, I don't like how that is. too high. So let's do it again. Let's do it a little bit lower because I have more room. So I have y equals 2 times x squared plus 3/2 x plus my 9/16. I got to subtract 9/16. And again, I'm not adding a 9/16. I'm adding a 9/16 that's being multiplied by 2. So I got to multiply this by 2. And then don't forget the 3. Okay? Now, factoring. Who wants to learn how to factor this, right? Not really many people. However, again, remember, it's just b divided by 2. 3/4. Done. Cool. Oh, I'm pretty good at factoring. X plus 3/4. And again, you can check that. Is 3/4 times 3/4 9/16? Yes. Is 3/4 plus 3/4 3/2? Yes. It's 6/4, which reduces down to 3/2. Cool. Now this I can simplify to, I can multiply this by 2. So it'd be 18/16 and then reduce that. Or you could just simplify this to, 1/8. So therefore that becomes a negative. Oops, I already did the negative. What the heck happened? So that... Okay, let's write this up. So anyways, multiply this by 18/6 so that you could divide that by 2, which would be 9/8. Or you could just reduce that to 1/8 and you're good. And then minus 3. Nobody wants to multiply 9/8 times 3 or subtract 3. So let's rewrite the 3 as a fraction with a denominator of 8. So if I multiply this by 8/8, I get 24/8. So it'd be a minus 24/8. And then I have y equals 2 times x plus 3/4 squared. And 9 minus 24 is going to be 33. And over 8. Okay, so there you go, ladies and gentlemen. That is, oops, sorry. That is basically it for being able to write the equation in standard form. And again, this is just for using completing the square for a quadratic. And obviously that's really going to be our only main focus. But I wanted to kind of, a good way to introduce, since we've been dealing with the binomial expansion, it's a good way for us to be able to kind of look into the process of completing the squared. So to go from here to go into that method. So there you go. But again, once you have it in vertex form, you can basically go ahead and find all of this information that we did in the previous example. But that's it for binomial expansion. Now we're going to get further in detail on our polynomials. Wait for you in the next video. Thanks.